Okay, now let's find a leg of a right triangle. Use Pythagorean theorem as well. In the first problem, it says one of the legs is 8, but the hypotenuse is 17. Just a quick reminder, we can still use our triples. So 8, we're looking for this missing side, and that is one of our triples if we'll look up here. 8, 15, and 17. So therefore, if your hypotenuse is 17 and one of the legs is 8, the other leg must be 15. So you can still use your triples. Next problem, and I believe these first 2 or 3 problems will all be triples. One leg is 12, hypotenuse is 20. If you can reduce the triangle, same thing. Both of those will divide by 4, which gives you a 3 and a 5. And I believe that's another triple. That'll be a 3, 4, 5. Since we divided by 4, we now must multiply by 4, and that gives us a third length of 16. If one of our legs is 50 and the hypotenuse is 130, this is also going to be a triple problem. We can divide each of those by 10. That gives me a 5 and a 13, which would be a 5, 12, 13. Since I divided by 10, multiply back by 10, and that's give me 120 for my third side. Now, on these next few, we'll actually have to use the Pythagorean theorem. And again, reminder, if the leg is 5 and the hypotenuse is 7, leg squared plus leg squared is equal to hypotenuse squared. So what's different about these problems is you've got a hypotenuse and a leg and the other leg missing. 5 times 5 is 25. 7 times 7 is 49. Just bring your answer straight down. Now here's where this is different. To take 25 to the other side, if it's a positive 25, we can turn it into minus 25 and we can subtract. That gives me b squared is actually 24, so therefore b is the square root of 24. Now on these problems, something I want to show you, we need to simplify any time that a radical is able to be simplified. And here's how we do it. We take 24 and we split it into anything that multiplies to give you 24. I know that 4 times 6 is 24. Now, if one of these numbers is something you can take the square root of, I know the square root of 4 is 2, so I'm going to mark it out, and I'm going to bring it out front and write 2 instead. So therefore, my b value here is 2 and root 6. Again, what I did, if there's a radical, if there's something you know inside the radical, the square root of, it can be brought out, and you actually did the square root of it. We'll show you again on some other problems. One leg is 6, hypotenuse is 9. We're going to divide them both by 3. That gives me a 2 and a 3. Leg squared plus leg squared equals hypotenuse squared. 2 times 2 is 4, plus b squared equals 3 times 3 is 9. To move a positive 4 to the other side, we're going to come over here and do minus 4. B squared is now equal to 5. To get rid of a square, we square root. Now, the square root of 5, it's not going to be able to be simplified. We don't have to worry with it. Why? Because there's nothing that multiplies by 5. 5 times 1 is it, that we can actually bring out front that would be helpful. Since we divided by 3, we will now take our answer and multiply by 3, and we get 3 root 5 as our final answer. Last one. One leg is 8, the hypotenuse is 16. We're going to divide by 8, 1 and 2. We're going to shrink it down. Leg squared plus leg squared equals hypotenuse squared. And again, remember, the hypotenuse is always across from the 90. 1 times 1 plus b squared equals 2 times 2 is 4. Move the 1 over. Since it's plus 1, we're going to subtract 1. It gives me b squared is 3. To get rid of a square, we square root. It's the same set of steps over and over. So therefore, my missing side is root 3. Since I divided by 8, I will now take that answer, multiply by 8. Remember, you can't multiply a whole number times a radical. We're going to leave them separate. My final answer is 8 root 3.